recording the video. Okay, good afternoon, by the way. Let's begin. Question number 4. Question number 4. Let me draw it. You have a circuit over here, and combination of series and parallel circuit, resistors. So here we have one. Here we have another one. We have here another one. Then goes like this, and one here. All right, and then you have one at the down part. Okay, then this is gonna be our circuit. Okay, this is the circuit. So let's write the magnitude of resistance. Over here is 3 ohm. Here we have 10 ohm. Here we have 5 ohm. And here we have 4 ohm. Here we have 3 ohm. Okay. So let's name the resistors. It's going to make our job easier again. So when you name the resistors, it's going to be easy for you guys to solve the questions. So let's call this one R1, here R2, this one R3, this one R4, and this one, let's call it R5, okay? So first of all, since it's a combination of resistors, first of all, let's make them series, okay? So to make them series, what are you gonna do? You see here, there is a parallel combination between R3 and R2. Let's first find over there the resistance over there. For 1 over, since it's parallel, we are going to use this one. Okay? 1 over R2, 3 equal to 1 over 2 plus 1 over R2 plus 1 over R3. So 1 over R2, 3 is going to be 1 over 10 plus 1 over 5. Again, they are not like fractions, so you have to make them like fraction. When you multiply here by 2, you're going to make them like fractions. So it's going to be 1 over R2, 3. When you multiply here by 1, it's going to be 1 plus 2 times 1. It's going to be 2 over 10. So you're going to find, and then at the end, when you find it, you're going to flip-flop it again. Find R2, 3. So you're going to find the R2, 3 as 10 over 3, which is going to be 3.3 ohm, okay? 3.3 ohm for R2, 3. So now our circuit is going to be like this. Let's draw it again. Yeah, enough over here. So here the circuit is going to be like this. Here we have 3 ohm. Here is going to be 3.3. Here we have 4. And at the bottom part we have 3 ohm again. Okay, so now the circuit turns into like this. Okay, so here what we have 3 ohm. Okay, let me change the color. So again, this is R1, R2, R2, 3. This one, this is R3. This is going to be this is R4. This is going to be R5. Okay, so let's find again. Let's find for other 2 couple. Okay, for other 2 couples means these 2. They are series right here. Since they are series, let's find it. To find a series equivalent, what do? You just simply add them, okay? So R2, 3, 4, let's say. So it's going to be R2, 3 plus R4. We're just going to simply add them. So we have 3.3 ohm over here plus 4 ohm. When you add them, you're going to get 7.3 ohm, okay? 7.3 ohm. So now our circuit is going to turn something else. So let's go forward. Let me change the page and I can show you. Okay, now the circuit is going to be like this. Again, we have EMF over here. Alright. We have this. Branches. Another branch. Now we have 3 resistors over here, okay? So this is R1, still 3 ohm. We find R2, 3, 4 as what? 7.3 ohm, okay? And our R5 is 3 ohm, okay? So now our job becomes much easier when you compare to the before. Now what we need, Again, let's find here, this time this part, and make our circuit series. So again, these two are parallel to each other. So it's going to be R2, 3, 4, 5 equal to 1 over R2, 3, 4 plus 1 over R5. Okay? So 1 over, let's call this one equivalent 1. Okay, R equivalent 1. It's going to make our job easier. Equal to 1 over 7.3 plus 1 over 3. Okay? So here again, we have to make them like fractions. So we can multiply here by 7.3 and here by 3. So 1 over R equivalent 1 is going to be equal to 3 times 1. It's going to be 3 over 21.9 plus 7.3 over 21.9. Now they are like fractions as you see over here. So you can add the numerators over here. There's going to be 1 over R equivalent 1 is going to be equal to 10.3 over 21.9. So this is 1 over. So again, you have to flip-flop it. You have to change numerator and denominator. Find out 1 over R equivalent 1. So R equivalent 1 is going to be equal to 21.9 over 10.3. So when you divide these two, what are you going to get? Let me just quickly tell you, 21.9 over 10.3. We're going to get 2.12. Okay, so our equivalent one is going to be 2.12 ohm. Okay, so now we have last step. Now our circuit is going to be a series circuit, a whole series circuit. Just a second, guys. I need to. All right. So now our circuit is going to turn into series circuit. Okay. So it's going to be like this. We have R1 over here and we have R equivalent 1 here. Okay. The circuit will be like this. Here we have EMF. Here R1 is 3 ohm. And R equivalent 1 we find as 2.1. Okay. 2.1 ohm. Since now they are series, we can find the R equivalent. R equivalent equal to R1 plus R equivalent 1, okay? So it's going to be 3 plus 2.12, that is going to be 5.12. So this is the answer of A, 5.12 ohm, okay? So R equivalent is going to be equal to 5.12 ohm. This is the answer for A, okay? Any questions so far? I think you don't have it. Okay. So second part in B is asking you if a 4-watt power supply is connected. What is going to be EMF? What is going to be EMF? For B, you are looking for EMF. EMF means potential difference, okay? That means voltage. So remember yesterday we did I showed you a formula about power. So power equal to current times voltage, or you can replace current. Since we don't have current over here, we can replace current by what? By V time V over R, okay? So our formula for power is going to be V square over R. Okay, this is going to be our formula. V square over R. Okay, so we are looking for V square. So let's crisscross them. Here there is one. So V square will be equal to P times R. Okay, P times R. Power times resistance will give us what? Will give us potential difference or EMF. Okay, so then V square equal our power is given as 4 watt, and we find the equivalent resistance as 5.12 ohm. Okay, so now we are looking for V. So let's put them here in the formula. 4 times 5.12. Okay, since it is V square, let's take them into the square root. Okay, so then we're gonna find the V over here. 4 times 5.12. When you get that, you're gonna get around, when you get the square of it, we're gonna get around 4.5 volt. Okay, so the V will be 4.5 volt. That is going to be EMF. Okay, EMF equal 4.5 volt. This is the answer of B. Okay. Any questions? No questions? Good. Let's go to number 5 then. Number 5. Okay. Let's move on to number 5. Number 5. Let me just read out the question here. Number 5. Number 5. What is it? Here, number 5. A light bulb marked 75 watt at 120 volt is screwed into a socket at one end of a long extension cord, in which each of the two conductors has a resistance of 0.8 ohm. The other end of the extension cord is plugged into a 120 volt outlet. Draw a circuit diagram and find the actual power of the bulb in the circuit described. Okay. First of all, we are gonna draw the diagram, and then we are gonna find the actual power described for the bulb. Okay. So let's go ahead. Let me just speak to you guys. Guys, if you don't use your mic, please mute yourself. Okay. If you don't use it, just mute yourself. All right, number 5. So first of all, let's draw the diagram. Let's draw it. So 120 volt outlet. We have 120 volts, we equal 120 volts. Here we have a bulb, okay? This is our bulb. Here we have two resistors. They are series, okay? They are 0.8 and 0.8 ohm, both of them, conductors. So first of all, this is the diagram, okay? This is the diagram that we draw it. So let's first find the resistance in the light bulb, okay? Resistance in the light bulb. To find the resistance in the light bulb, we are going to use the power formula. Power equal to what? In the previous questions, you see it. Power equal to V square over R. Okay. So we are looking for R. So let's crisscross it. So R will be equal to V square over P. Okay. What is our V square? Our V is given us 120 volt, as you see over here. So 120 square over, and the power is giving you 75 ohm, right? It's giving you 75 watt. Okay. So when we do this, at the end we are going to find the resistance of the bulb as 75 ohm. Okay. So this is the resistance of the bulb. Okay, this is the first part. The second part, when placed along the extension cord, the light bulb in series, as you see over here, they are in series, right? So two of the conductors, so we are going to have now, find the R here is 75, right? Okay. No, wait. No, sorry, we find, wait. Let me just do calculation, guys. I think I did a mistake over here. It's going to be 192. I just did the calculation. So 192. Oh, sorry, guys. So now, let's put it here. So we have 192 over here. We have 0.8 and 0.8 over here. Since they are series, we can find the equivalent resistance for all the circuit. So it's going to be 192 plus 0.8 plus 0.8, okay? So R equivalent will be equal to 192 plus 1.6. It's going to be 193.6 ohm. This is the equivalent resistance, okay? Why do we need this? Because we are going to find current. Without knowing the equivalent resistance, we cannot find the current. So let's apply Ohm's law. Wait, let's apply Ohm's law. So apply Ohm's law to find current, okay? Find current. So to find current, let me give you a triangle again. VIR. When you cover V over here, when you cover it, you're going to see that it's going to be V over R, okay? So RB again is 120 over 193.6 equivalent resistance. So when you do that, you're going to get the current as 0.62 ampere. Okay, 0.62 ampere is going to be our current. This is the third step. First step, we find the first step. Here we find the resistance of the bulb. Second step, we find the equivalent resistance. And third step, we find the current which flows inside of the circuit. So the last step is asking us power dissipated by the light bulb. So in order to get this, you already find the current and we have the resistance. So to find the power dissipated into the bulb, power equal to current times current square times R. Okay, current square times R. Where did this come from? Again, it comes from here. When you apply the Ohm's law over here, you are going to get this formula. Instead of V over here, you write R times I. Okay. When you replace V over here by R times I, you're gonna write this formula. Okay. So let's find the power then. Power equal. We found the current as 0.62. So 0.62 square times the R is 193.6. So when you do this, you're going to get the power as, you can do the calculation, 73.8 watts, okay? 73.8 watts. This is going to be the answer of question number 5, okay? 73.8 power dissipated by the light bulb, okay? So lastly, we have question number 6. Question number 6, what is asking you in question number 6? That we're done. I'm back, just a second. We are looking for number 6. Let me just share with you guys. Where is it? Okay, number 6. We have 360 watts light bulbs which are 120 volts connected to 120 volts power source. The total power delivered to the 3 bulbs, we are going to find it, and then they're going to find the potential difference across each resistors. Okay, so first of all, let's draw for number 6, let's draw the circuit. Okay, let's draw the circuits. Sorry guys, network problem again. We got the problem, it's just disconnecting frequently. Sorry about that. So let's just try to finish number 6. Where is my? Okay, let me share with you. Okay, here. Okay, number 6. Let's go ahead, finish it. Let me draw the circuit for you guys. Number 6. We have one bulb over here, one is here, and the other one is over here, right? Okay. So each of them, they have 60 watt and 120. 100. Let's find the first R actually. To find the R, what are you gonna do? Again, P equal V square over R. Find R, okay? So to find R, we're gonna do it like this. So V square is 120 square over, when we crisscross it, it's going to be our power 60 watt. When you divide these two, you're gonna get the resistance is 240 volt. Okay? So when you get the resistance 240 volt, here is going to be 240 volt. Ohm, sorry, here is going to be 240 ohm. What about here? How can you get over here? It's easy to get it. To get the equivalent resistance, we are going to do like this: 1 over equivalent equal to 1 over 240 plus 1 over 240. Okay? So then the equivalent resistance is going to be 2 over 240. When you flip-flop it, like when you change denominator and numerator, the equivalent resistance will be 240 over 2, which is going to be 120 ohm. Okay? So this is the equivalent resistance. So first, let's find the power. The A is asking you what? What is asking you in A? Let me just check it out. He's asking you the total power delivered to the 3 bulbs. So the total power delivered for the 3 bulbs, we are going to do like this. Power equal to, just the first step, second step, third step, okay? Power equal to V square over R, okay? We are going to use this formula. Our V again is 120 square over, we find the equivalent resistance for these two as 120, we had over here 240, right? So when we add them, equivalent again, let's make it 240 plus 120, it's going to be 360 ohm, okay? So when we add them, it's going to be 360, let's divide to 360. So when we do this, you're going to get the power for each bulb is going to be 40 watt, okay? So we're going to get 40 watt for each bulbs. So it's going to be 40 watt over here, 40 watt over here, and 40 watts over here, okay? This is going to be the power. For B, what is asking you? First, you have to find the current, okay? First, we have to find the total current for B. Let's go ahead. Again, when we add the like R2 and R3, they're gonna get R23 here, okay? They're gonna have R1 over here. They're gonna make a series circuit. Okay, so R equivalent again is given us, as we found it actually, 360 ohm. So since R equivalent is 360 and the V is 120, we can find the total current flowing through here, okay? So the current is going to be equal to V over R, okay? V over R, which is going to be 120 over 360. These two, they're going to cross out each other. So 12 over 60, it is going to be 1 over 3. That is going to be 0.33 ampere, okay? So this full ampere, full current we have here is 0.33. So to find to find the voltage for each resistors, what we're gonna do again? V1, let's call it here V1, and here is going to be V23 because they are parallel. Their voltage are going to be the same according to Ohm's law. So to find the V1, what are you gonna do? We're gonna multiply I times I. Again, I is gonna come up. I times R1. Okay. So I times R1 will give us the first voltage or the voltage on R1, the resistors 1. So the current we found, let's say 1 over 3, 0.33 equal to 1 over 3 again. So 1 over 3 times, what is R1? 240 again, times 240. And then you're going to find the V1 as 80 volt, okay? So V1 is 80 volt. What about V2? How do you find V2? This time to find the V2, 3 actually they are the same. We are going to multiply I times R2, 3, the combination of R2, 3. We found, remember, 240, okay? Equivalent resistance is 360, let me write over here. R1 is 240, R2, 3, the combination we found 103 ohm. Okay, so then let's put it here 1 over 3 times 120, then we are going to get 40 watt for V2 and V3, okay? So that means the V1 is going to be 80, the V2 is going to be 40, and the V3 is going to be 40. Because V2 and V3, they are parallel to each other, they have to be the same, okay? Since they are parallel to each other. And that is going to be end of the question. We can, this is end of the actually assignment, okay? We are running out of time.